today's lesson, we're going to explore the idea of like radicals. Similar to like terms, what you're going to look for is to see if the radical symbols actually match up. If they match up, then you can add or subtract them together. So, like we just talked about like terms, if I have 3x and 5x, we can add these together by adding the coefficients and we get 8x. Now let's say I change that to 3x squared plus 5x. Then we want to be able to add those together because the exponents don't match up, and therefore they're not like terms. But if I change this to 5x squared, again they match up, and we add the coefficients, so we get 8x squared. Now what we're going to be looking at today is to make sure that the radicals match up. Now the difference with this is we have to pay attention not only to the radical with the index, but also the radicand. So if I have something like 4 square root of 3, it can be only added or subtracted with something that is square root of 3. So let's say 2 square root of 3. Let's say I'm adding those together. Again, you're going to be adding those coefficients in front to get 6 square root of 3. You don't multiply them or anything like that. You simply add the coefficients. Now, let's say that this back one was actually the cube root of 3. Because the indexes don't match up, you can't actually put them together. Therefore, they have to stay separate. The only way that you could do that is if they were both the cube roots of 3. And again, you would add the coefficients and then keep the index with the radical and radicand the same. So now let's look at number 1 and number 2. If you take a look at those, you'll notice that the radicands aren't the same. The indexes are the same, but the radicands aren't. So you're going to have to do a little bit extra work. You're actually going to have to try to simplify each radical to see if the simplified version will match up. So if I take the square root of 50, I know that 25 goes into 50, and 25 is a perfect square. Goes in twice. Square root of 25 is 5. And the square root of 2 breaks down. So square root of 50 becomes 5 square root of 2. I'll look at square root of 18, and that's going to become square root of 9 square root of 2, which is 3 square root of 2. But I'm going to have to multiply the 5, sorry, I kind of scratched that out, the 5 with this 3. So this term actually becomes plus 15 square root of 2. Now if I look at it, even though they started with different radicands, they ended up the same. So they both have the index of 2, radicand of 2. I want to add those coefficients, so it's 20 square root of 2. Go ahead, pause the video, see how you can do on the next 3. They're a little bit more complicated, have a little bit different twist to it, but go ahead and see how far you can get. Okay, number 2, you should have noticed that the index is 3, so this kind of makes a little bit different. Remember in previous videos I said it's going to be helpful to have kind of a cube list. So if this is our cube list, we know that 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, and I think that should kind of do it for right now. So we're going to use that list, and we're going to break down these numbers. So cube root of 24, you'll see that 8 can go in there. It can go in there 3 times. So we'll do the cube root of 8, cube root of 3. Cube root of 8 becomes 2, so we have 2 cube root of 3. Then we'll work on the cube root of 92. And 64 can go in there 3 times. And we know 64 is on that list, so that's going to become 4 cube root of 3. But remember that also has a 4 out in front, so it's really 4 times 4, which is 16 cube root of 3. And then finally, the cube root of 3 cannot be broken down, so we're going to leave that as is. So 3 cube root of 3. They all match up with the index and the radicand, so we're just going to go ahead and do the operations. 2 minus 16 is going to be negative 14 cube root of 3 plus cube root of 3 will give you negative 13 cube root of 3. The same thing applies when we have variables. You're going to have to reduce them and simplify them, or simplify them just to make sure that the indexes and the radicands do come together. So I'm going to do the first one. Index is 2, if you remember. And so I'm going to break down the square root as 32 normally. That breaks down to the square root of 16, square root of 2. So it's 4 square root of 2. And then I take the index and I see how many times it divides into x to the 5th. And it goes in twice. So I'd pull out an x squared, but there's 1 left over. So this actually becomes 4x squared square root of 2x. I'm going to do the same thing with square root of 18. That's 9 and 2. 2 goes into 5 twice, so I can pull out x squared, and there's 1 left over. So then this becomes 3x squared square root of 2x. I apologize, that should have been an x right there, because there's 1 x left over. And finally, we're going to go to the cube root of 24. Now this is a little different because it's the cube root. So I'm going to have to do the cube root of 24, think about what goes in there. And 8 goes in there 3 times. So that becomes 2 cube root of 3. 3 goes into 4 once, so I pull out 1x, and there's 1x left over. So that's 2x cube root of 3x. And if we compare these first two are the only ones that match up. So we're going to add those together. 7x squared square root of 2x. And since this doesn't match up, that just gets added at the end. Number 4 is a little bit different because we have fractions. What we're going to do with this is we are going to simplify the radicals, and then we're going to deal with the fraction component. So square root of 75 becomes 5 square root of 3, because it was 25, then 3. So I have 5 square root of 3 over 9 minus square root of 3 over 2. Remember that with fractions you need a common denominator. So my common denominator is 18, so I'll multiply this one by 2 over 2, and this one by 9 over 9. And that's going to give us 10 square root of 3 over 18 minus 9 square root of 3 over 18. You only multiply the coefficients. You don't multiply a whole number within a radical. So those stay separate. Same here. There's an imaginary 1 right there, so you multiply the 1 with the 9, and the square root of 3 stays underneath. Then you'll keep going. We already have a common denominator. Those are like radicals, so I'll get 1 square root of 3 over 18. One thing to really pay attention, especially in this one, you cannot divide the number 18 or any number that's outside a radical into something that is a radical. Alright? They have to both be under radicals in order for you to reduce them. If one's underneath and one's not, you cannot simplify those. And this brings us to the last part of this section, multiplying radicals. And we briefly talked about this in example 4. When you go to multiply radicals, and in this case you would be distributing to each term, you can multiply this 2 with this 10 because they're both underneath square roots, the same index. But you cannot multiply something that's underneath a radical with something that's not. So when I distribute that first square root of 2, I leave it as 6 square root of 2, not 12. Then I do plus square root of 20. So I can multiply the 2 and the 10 because they're underneath radicals with the same index. From here, what you're going to want to make sure is that you can't simplify any radicals further. So square root of 20 is 4. Square root of 4 times square root of 5, which is 2 square root of 5. Now, these don't have the same index, so we'll leave those separate. But we do want to try simplifying. And when we see something with binomials, we're still going to go back to that pattern that we talked about before. When you multiply two binomials, you're actually going to FOIL. So I'm going to take this 5y, multiply it by 5y. And because they're both underneath radicals, you're going to get 25y squared. And then I do the outer, which will be minus 2 square root of 5y, because one's underneath and one's not. Then I do the inside. Then finally the out. Now, you should notice that this is actually going to result in a dots problem because these two cancel out. And you'll notice we're left with binomials and they're both squared. So this becomes 5y, take the square root of both of these, minus 4 is our final answer. Our last example for the day has a binomial squared, but it doesn't look like your typical binomial. You'll notice that we have the square root of x minus 1 as one of the terms. But let's work this out. Knowing that it's squared, that means that there's two of them. So I'm going to have the square root of x minus 1. I'll do plus 2. Now, if you remember any of the patterns like PSTs or dots, you certainly can use this here. But I'll show you how it kind of works out. So I'm writing it out both, and what's happening is I'm going to multiply this by this. And when you do that, because these are both square roots, they actually cancel each other out, and we get x minus 1. And the reason why that is because if we look over here, it's x minus 1 times itself. So that would be x minus 1 squared. And the squared and the square root cancel each other out, and you're left with the x minus 1. Next thing you're going to do is the outer. So I'm going to get 2 square root of x minus 1. Do the inner, which will also be 2 square root of x minus 1. And finally, I'm going to do the last, which is plus 4. These are like terms because the index and the radicals are the same. So I get 4 square root of x minus 1. I'll add my like terms, negative 1 and 4, which is 3. And then I drop down the x. So there's my answer.